severe and non-uniform liquefaction damage of reclaimed ground contributed by interference between body waves and stratigraphic irregularity-induced surface waves, by Dr. Kentaro Nakai. The 2011 off the Pacific coast of Tohoku earthquake caused extensive liquefaction damage to reclaimed land along the Tokyo Bay coast, even though it was approximately 400 km from the epicenter. The characteristics of the liquefaction damage include the fact that liquefaction occurred in soils with a high percentage of fine particles and that the distribution of liquefied and non-liquefied areas was non-uniform. The factors contributing to such non-uniform liquefaction damage included the heterogeneity of the ground materials and their depositional conditions, and the effects of the long earthquake duration. Although these points are certainly valid as reasons for the occurrence of severe liquefaction damage, they do not fully explain the mechanisms of the liquefaction of the fine-grained soils, or the localized extent of the liquefaction. To elucidate the severe and non-uniform damage, seismic response analyses of a multi-layered ground were conducted focusing on the stratigraphic irregularities in the ground beneath Urayasu City. The results showed that the thicker and softer sedimentary layers amplify the slightly long-period component of the seismic motion and increase the shaking at the ground surface. Moreover, the wave propagation in the ground became very complicated owing to the focal effect caused by the refractions and reflections of body waves at the stratum boundary, surface wave excitation at the base of the slope, and amplified interference between body and surface waves. This complex wave propagation contributed to non-uniform surface ground shaking and severe liquefaction damage. In addition, surface waves, which consist primarily of slightly long-period components, can propagate far and wide. As such, they triggered extensive damage owing to delayed shaking phenomena that continue even after the earthquake. The analysis results suggested that multidimensional elastoplastic seismic response analyses considering stratigraphic irregularities are important for detailed seismic evaluation.